Okay, thank you. Let me know once you're able to see my screen.
Yeah.
Okay. I'll start with a quick recap of what we have done so far in the first 2 weeks. We started with the introduction to NLP. What is NLP, and what are the different areas where it is being applied? So this was the plan for the 4 weeks. We are off by 1 week with respect to the plan, because I think the second week there was a request that we had to go through the text reading and the regex part again. So I did a review of that. So, and we also shortened the session. So we are covering in week 3 what we were supposed to close by week 2. That is text pre-processing. Those are the topics which I'll be covering today. We'll decide how we'll go about for information extraction and text classification, semantic sentiment analysis, like how we can go about it. Of course, there will be a topic cut. I'll have to look at what will work out fine for one session and then plan that. See, so far what I have done is I've introduced NLP, and I've just started the work that needs to be done before going to the actual model building. I would want to give at least one example where we are doing, say, for example, sentiment analysis or something where you can see how it is being applied, and work that through more like a real world example. I will see how I can accommodate that in the next week. We have some portion left for information extraction, like for example, part of speech tagging, dependency passing, named entity recognition. Those things are all, these are all preparatory things which with which, like, you complete that and then you go to the actual model building. Might not be applicable in all the cases, but these are general preparations which you need to do when you're doing an NLP model. So um, so I'm covering one part of it now. So if you look at the pipeline, the first thing is you start ingesting the text file, right? So that is what we saw in the first session, where we have different ways of taking in the text file. If it's a CSV file, we just read from pandas, and then we do some exercises with some stuff with pandas to get to what we want. And if it is text file, we saw how the text file can be opened and read with just if it is going to contain uh, if it's a labeled text file, we saw how it can be split into the actual text and the label, that is the positive or the negative sentiment, if you remember that portion. So we did that, and a very integral part of preparing the file before you submit it for an NLP model is regex and few other things which you are going to see today. Regex is more like a regular expression. If you have to, it's basically a pattern which you have to find few things out, search for few things in a text file. It will be useful for uh, either cleaning the text file or coming to conclusions from the text file. So that is what we saw last time. Regex is regular expressions, and today we are going to see text pre-processing. I'll introduce the topics a bit later, and after that I'll see how we can go to information extraction, have a maybe a quick introduction to information extraction, which will cover part of speech tagging, dependency parsing, and named entity recognition, and see whether I can go for a quick example of NLP application. That is something which we can plan for next week. So today we are going to look at text pre-processing. We saw what were the applications of this, and reading text file, we saw how it can be done. I gave the code for this. Code snippets are here. And label text file, we saw how it can be split. Like once you have a label, you read the text content, how it can be split between the actual review and the label, the sentiment or positive or negative sentiment, if you remember that. And after that we saw regex, sequence of patterns, what are character patterns, what are quantifiers, we saw that. And now we are moving to text pre-processing. Okay, the topics we are going to cover here are tokenization, stopword removal, and normalization. Okay, the terms might be new for many, but I'll cover this one by one. And what I'm going to do is, like, I have 3 slides prepared for each of these topic, three slides total. I mean, one slide for each of this topic. I will introduce the topic and show you the Python code. That's the way I'm going to work it out. So with this, I'll start with tokenization. What are what is tokenization and what are tokens? It's tokens are actually the smallest unit of textual content. So when we say smallest unit, it can be anything, right? So you have text, like we look at this para itself, like what would be the smallest unit of text of this text content? We can say that it can be more like something which can stop at word level, or it can be something which you can do at a more detailed level, or you can have like character level tokenization or subword tokenization. Like if you want to say if you want to split it between say you know minimalist, so it's going to be minimal and ist, right? So if you want, that is subword tokenization. Character level, as the name explains, it's like each character, or it can be left at word level itself. So basically you're looking at for a textual content which you're trying to process, tokens are they play a very big role. You find the smallest unit of textual content, and many models, deep learning models, which are for built for NLP, and a lot of NLP models use tokens as the primary i- sources of input for them to come to conclusions about what is expected out of them. So tokenization is an integral part, and it is to get to the smallest unit of textual content. Okay, and those that smallest unit are going to be called as tokens. Tokens can be words, it can be characters, or it can be subwords, that smaller part of the words. Okay, so that's why the classification comes in. If you look at tokens, what the way you build the whole thing is, you take tokens and then you put few tokens together, it becomes words. If it is character based tokens, otherwise if words themselves are tokens, then if you put few tokens together, they become sentences. And if you put few sentences together, they become paras, and few paras put together, they become document, and few documents put together, it becomes corpus. So you'll always come across this, right? So this is when you're building an NLP model, you'll hear the term like, I built it based on this corpus. I have a corpus from all the Twitter feeds, or I have corpus from various social network posts, so I can do this. So what it means is, this is a sequence in which it is going to be the tokens. Depending on what type of tokens, it's either words or sentences, sentences to paras, paras to document, document to corpus. So that is how it goes. And these are, you need to look at building tokens for you to feed it into the model, for the model to work fine, to give you the desired result. So this is tokenization and why it is being done. I would like to introduce another term here, vocabulary. All these they sound very generic terms, and they are also similar to what the general English meaning is. So vocabulary is the list of unique tokens in a textual content. It's very simple. If you have like several tokens which are with repetition, you're going to just take the unique ones, so it becomes a vocabulary of that textual content. So we have spoken about tokenization. What are tokens and why it is being used, and why do we have to do that, and introduce few terms. So what are the different types of tokenization? You have white space based tokenization and spacey based tokenization. White space is very simple. All that it does is it takes white space as a separator and just splits it based on the white space. So it's a very simple way of doing the tokenization. So you have like this line, it will just split the, if you're taking tokenization as a way of separating a piece of text into smaller units called tokens. If this is the text you're giving it, and if you pass it to a white space tokenizer, what it will do is it will give the tokens as tokenization is a way, those will be the tokens, basically split with white space. Okay. Other way of doing tokenization is spacey based. Now I'm introducing a library to you, which will be used a lot in NLP. So spacey is a Python library which you can use. It's built for natural language processing. So they have like spacey, that there is an algorithm with which they do tokenization. Since there is an algorithm and not just based on white space, it is going to be more reliable, and it will give you better results. So we'll see that shortly in the code, but the general advice is like you can look at spacey based tokenization for better results. So some areas where, like for example, if your sentence contains $11,000 or something like that, if it's white space, it is not going to split $11,000, but spacey we'll look at those things too. So there are a few other examples like that with which there's some amount of intelligence, and they have a sequence of steps with which they do the tokenization. So it is more reliable for you to do this. So I'll pause here for any questions on the theory of tokenization before I move to the code. Okay, I'll take that as a clear understanding, and then I'll move to the code. So we are starting with tokenization. So I've taken a text, for example, like I'm playing basketball for the US national team and I earn 11,415 an hour. I've just assumed $100 million a year and just split it, just an imaginary sentence. It need not be referring to anyone. So if you do a white space tokenizer, what it does is, like, if you can just do a text dot split, the split function will do it based on white space, and this is what it does. So it just creates based on the space, and then it gives you this. Now I'll start looking at what can be done with spacey. Okay, so now I've imported the spacey library. In case you don't have spacey installed, you can do a pip install and get the spacey installed in your distribution, and then start with import. And then I load a model. There are few types of models. I've taken the smallest of all, the low volume model. And so I've taken the language model. This is English Core Web SM. SM stands for the small portion of it. So load this language model based on which spacey does the tokenization. So this is where we are giving like what language, what model it has to use for us to do the operations, uh, the text operations which we are looking at. So I'm loading that model, and then I'll create a doc object with that, with the text file. We'll see what doc object contains, but first just go with the flow. So we'll create a doc object. So there is something called doc object. What does it contain? So it's like, if you look at it, you see the type of doc object. Actually, it is, you can see it very clearly. It describes, it doesn't make any it's just a type which it's just an object like any other, object oriented thing. So what it contains is what we're going to see. So in the doc object, what we need to do is, like, it has got tokens. So you ask for printing each of those tokens. What it does is, it you go through each token in the doc object and print it out. So you have a for loop where you're iterating through the doc object and printing the token. So you do that, and this is the result you get. You get a list of tokens, and you have this here. So you take this. If you notice, there is a difference between what you're getting here and what you're getting here. If you notice, say the dollar example which I mentioned, right? So you already have this. There is a tokenization algorithm which is coming into play, and then the splits are being done. Now we have gotten the tokens. Can we pass it to the model? What we need to do is, we still, if you look at the type of the token, if you look type of each token, it is still, belonging to the token part of it. Like, it's still not in the textual form. So we can convert it to the textual form by, you know, accessing token.text for the token. So basically we are converting the tokens into a textual form for us to do the further processing. So we are doing that here, and just use token.text for each of the token. Then you will get it this way. With this, you have the tokens in the textual form, which can be used for passing information to the model you're trying to build. This is one of the text pre-processing steps which we will do before we pass it on to the model. So this is a quick introduction on tokenization. So a quick review. I told you what is tokenization, what are tokens, what are the different types of tokens, what is the link between the to token and the textual content which is there. There is a sequence which is followed. Like, you have the token, you have sentences, you have paras, you have documents, and then you have the corpus. I introduced vocabulary, and after vocabulary, we saw two types of tokenization. One is a white space, which is very plain splitting of text with just a white space as the delimiter. And the other one is a spacey based tokenizer, which has got some intelligence in building the tokens. And we saw how it is being done using spacey. So with this, the introduction for tokenization is completed. Any questions at this point?
This the spacey library, Harsha, it basically created this dollar and amount as two separate tokens or token tags,
Right,
right?
right.
So is there a specific reason? Like, let's say if it's a not a number, and if I just say dollar and ABC, is it still going to separate them or?
It would separate, I think, because it is going to see whether there's special character, and there are a sequence of steps. I can share it later in a PPT too. There is a sequence of steps with which it's going to see. Say if you want to analyze, like you want to get the significance of that word. If you're saying dollar 2000 or dollar 11,415, as I've mentioned here, if you want to get to the significance of that amount or some work that needs to be done with that, then this will help, right? Instead of having it as a single textual content dollar 11,415. That's why Spacey splits it this way.
Okay. And and is it also considered the localization? Like, because if we talk about different languages like French, the number is represented in a different way, right? Like the separator is a space and comma. So is it also takes care of that as well?
Right. The model which you load here will determine that. So what you here we have loaded English, this one, right? So if you're going to give it
Okay,
in
okay,
French, that
okay.
should take care of it.
Okay. Okay. Thank you.
Hello. Please, can
Yeah.
you go through the spacing looking again? I had a bad
Sorry,
follow.
your voice is breaking. Can you please repeat?
I said, can you go through the spacing token again? I had a bad network, so I couldn't follow.
Yeah. Okay. I've come here. What is the question?
Yeah, I think I said, can you summarize it again? I couldn't follow what you.
Okay. So tokenization needs to be done uh, before you pass the textual input to several language models. So many models use the tokens for them to, for the natural language processing to be done. For doing this, like tokenization is basically splitting the textual content into it's a smallest unit for the text. It can be of several types. It can be words, it can be characters, or it can be subwords also. The tokens can be of three types. Um, well, I'll not get into like which one is used for what. That might be a bit advanced. So, but uh, for now, let us assume that you're splitting it into the basic level of words. Okay. So when you're trying to build the tokens from a textual content, you can do it in two ways. One is just have a simple white space tokenization, which is, you just uh, split the textual content with white space as the delimiter. So whenever there is a separation with a white space, you call that a token. That's a very simple way of doing. And there is another way of tokenization, which is given by Spacey, which has got some, algorithm to do the tokenization. So you get more detailed results, more reliable results. So what you do is you read the textual content, okay, and you load the model for that language, create a doc object, and in the doc object, you read the tokens. That's the high level summary of what I have done here so far. And once you have the tokens, then you can pass it to the model for it to do the processing. So we still haven't gone to the model building process of natural language processing, but we are still in the pre-processing, cleaning, ingesting the file. That is where those are the topics which we have covered. Tokenization is one part of it.
Okay, thank you.
Okay. If there's no more question on tokenization, I'll move to the next one, which is the stop word removal. Okay, I'll take that as a go ahead for stop word removal. Okay, stop words. What are these stop words? Okay, stop words are basically the most common words in a language which are added to make things more meaningful, right? So you have articles, you have several things which come into play in a language when you add these things. See, in some model building activities, the stop words become noise. You're not looking at, you're not getting much value when you're parsing the stop words. So you need to remove the stop words for you to uh, get to the actual target, right? There are some cases where you need to retain the stop word. For example, if you're doing a translation, then stop words play a role in doing the translation. You should look at the sentence as a whole. But if you're doing something like you're trying to find the topic of a content, then you know that if you are going to give importance to these stop words, which are very common words which are being used, you're not going to get to the topic of the content easily, right? So you'll have to remove the stop words for you to do that. So there are some instances where you will have to use the stop words when you're doing the NLP NLP stuff, or some cases where you'll have to retain the stop word for you to do. So again, a quick recap. This is stop words are the most common words in a language which are generally used for adding meaning to the sentence what you want to convey. You're not just going to say, if you're going to talk about earth and moon, you're not going to say moon, earth, satellite. You're not going to do that, right? So you're going to say moon is a natural satellite for earth. That's how you're going to say. So you construct a sentence with several articles, several words, so that you convey the meaning to the audience. So in some cases, if you're doing, say, if you have several such sentences and you want to find what is the topic of that textual content, you don't know what the topic is. And if you want your model to determine what the topic is, then you don't need the stop words there, because you'll, if the model is going to take that in, it's going to be more noise, and the processing is going to, it's not going to give you the right result. But if you remove the stop words, say, for example, moon is the natural satellite for earth. So in this, if you're talking about the keywords here, it's going to be, we are talking about moon, satellite, earth, maybe natural also. The rest of the words are stop words which are not required for you to determine like what the line is talking about. So in some cases, in the model building exercise, we remove those stop words. When do we do that? When we are doing textual classification or caption generation, or if you want to generate automatic tags for a particular topic, then so in these areas we remove the stop words. There are instances where you don't have to remove the stop words too. Like, for example, if you're doing machine translation, because your translation depends on the complete sentence, like an each and every word which is there, so that you can do an appropriate translation in the other language. If you're doing some language modeling, like with which, like you're building the content of the language, so that is required. If you're looking at summarization of a text and question and answering problems, like if you we saw an application of natural language processing was when, in many cases, we can find it, like if you go to Fido or Rogers, and if you want to talk with a service representative, the first thing you encounter is a robo which does your question processing, right? So those cases, you need to understand the complete sentence as a whole. You cannot just look at, while the important words are going to have its own significance, but for you, for conversational purposes, it's better if you understand the complete line. So these are all cases where stop words should not be removed. So there are instances where stop words need to be retained. There are instances where stop words need to be removed. Depending on what the application is, we have the step or we don't have the step. Any questions about stop words? Okay, I'll take that as a no and then move to the code for doing this. So here, if you look at it, I'm using the same model which I had used, the language model, and it has got, for you to get the stopwords, default stopwords, you just use this command, you will get the stopwords. There are quite a few stopwords which Spacey has recognized. It will look at removing them. Okay, and how do we remove them? So you have built the tokens here. So what you can do is you you go for the text and just have a condition, token.stop is equal to false. So if you remove that, then what you can do is you will get the words removing the stopwords, which will be key. For example, here in the line, I'm playing basketball for the US for the US national team, and I earn $11,415 an hour. If you remove the stop words from this line, what you're going to get will be playing basketball, national US team, earn dollar, R, and it's also including the space and the period. So these are all things which are, the rest of the words are removed, like I am, all these are very, for, all these things, and everything is removed here. So this is what you will get after you remove the stop words. If you want to conclude, like for example, what this line is talking about. You can come to a conclusion. You can pass this input to the model, and the model will say, okay, this is what it is talking about. It will give an estimate of what this topic is about. I've just taken a simple sentence, but if you'll understand the significance of it if you take a para or a corpus of text and then try to apply this. So this is how stopword removal is being done with, once again, using spacing. So you get the tokens after you remove the stopwords, which can be passed to the model for the natural language processing. Any questions about stopword removal? Okay, I'll take that as a no, and I'll move to the next topic, which is going to be normalization. So normalization is basically arriving at the base word for a particular word. So a word can be uh, a base form of the word, which is called as morpheme, or if you're using lemmatization, it's called lemma too. And you have the word can have prefix, morpheme, and a suffix. Okay, out of this, prefix and suffix are optional, but the core is you have a morpheme, which is the base form of the word. For example, laughing, laugh, laughed, all these things, the base word will be laugh. Okay, and you have like you try to arrive at this base word with a normalization, which you want to do. So you can have like prefix for a word. If you're taking an example, pseudo secularist. Okay, so in this, if you look at it, pseudo is the prefix which is used to qualify the term secular, and ist is the suffix which is used there. So if you split this, you're going to have pseudo secular ist. Sometimes you might not have like you might not have might not have all these three components. It can be two components, but for sure you will have morpheme alone. So that will definitely be there. So normalization is the process of converting a word to its base form. There are two ways of doing stemming and lemmatization. Stemming is a very rudimentary way of removal of the inflectional form of the word. It's a very, when I say inflectional, like the example which I gave, laughing, laughed, laugh, laughable, all these things. So what it does is uh, the language knows, like, the system knows that, the the things which are the inflectional form about, ing or able, all these things will be removed, and it will arrive at the base word which is there. A very rudimentary form of doing this. This is stemming. Sometimes it can produce wrong results. Like for example, winning, it will just remove ing and say that winning is the base form is winn, but there's no word called winn. So it can give wrong things. So what can be the way of doing it? Then that's where lemmatization comes. Lemmatization is a systematic process of removing inflectional form of word. There is once again an algorithm. We are going to use Spacey to do that. It is advanced and it produces meaningful lemma, or lemma is the base form of the word, and it's a recommended way of normalization. So this is normalization. What I spoke about, the definition for normalization, what is being done, what are the two techniques, which one is better, is also something which I spoke about. So why do we do normalization? Why do we do normalization is when you pass textual content, see what we need to do is we need to find what it is actually trying to convey for it to, gather, get to a come to a conclusion based on the textual content, right? So it can have different versions of the same information, but it is like for example, if you're talking about the example which I gave, laugh, laughable, laughing, everything. So it everything is referring to the lemma of laugh, right? So if you can remove the inflection form of the word, then you have lesser processing for it for the system to do, compared to taking each and everything as a separate type. So it optimizes the whole thing, so it improves the efficiency. So that is why normalization is being done as part of natural language processing. So any questions about this before I move to lemmatization and show it in spacing?
No, Harsha.
Okay. So now it's very simple to get lemma. It's not going to take much time. So all that you'll have to do is for the token which you have built, use token dot lemma underscore for you to get the lemma. It's as simple as that. So you get the uh, say for example here if you see since you are using spacey if it had been the other type of stemming is what I'm referring to other type of normalization you wouldn't have had this. If you notice here you take the token and then you just find the lemma for each of the word token which is there. So what it does is am is converted to b, playing is converted to play, basketball remains for all these are the basic forms which are there. Of course these are without the stop word removal, and as I said, like depending on the situation you need to decide whether you need to have the stop word or not. But you see here that it is converting it to a more meaningful lemma where it is supposed to be say uh, we know that am is a form of an auxiliary verb, so be is the actual root for that. And there are different depending on whether it's first person or second person that you have different are. You are is going to be the form of be for second person. So these things are going to come into play, but it's converting it to the basic form which can be utilized for further natural language processing. So it's a very simple technique. So take the token, add dot lemma underscore, you will get the lemma for each of these words, which can be used for processing this. So here, if you see, like what I have done is like I've printed both the text and the lemma for each text in this. If you want only the lemma, you can just print this and get only that result for a particular corpus of text and take it forward for further processing. So this is normalization, and within normalization, we have seen how lemmatization is being done using spacing. Okay, I'll pause here for any questions about the topics which are covered here. Okay, so there's no questions I gather. So what I have covered so far in natural language processing is textual file ingestion, introduced regular expressions with which you will clean the data or come to search for a particular pattern in textual content. And I've covered like some text pre-processing steps in terms of normalization or uh, tokenization, first tokenization, and if required stop word removal and then normalization. So these things are all like we are still in the building blocks phase. We haven't gone to how we are going to build a model yet. So these things are required. It might be applicable for some cases, it might not, depending on what the ask is. We'll have to use one of these techniques, or maybe for sure we'll have to use some of the techniques to get to the model building level. And that is what we look at going to the next session next week. I'll also look at few other portions building blocks to like part of speech tagging or dependency determination, named entity recognition before we go to the actual usage of like seeing a real world example how it is going to be applied. So we are still in the building blocks phase. So I'm just giving a coherent. I'm just saying how we'll get it to a coherent set of topics. So with that, I'll stop for this session. So any questions you have, please reach out to me. Kader, with that, I think the session is done for today. Kader?
Hello,
Yeah,
Mickey. Can you hear me?
yeah,
Mickey, man.
Yeah, I
First, I
could.
want to.
Yeah.
Hello. Was somebody else trying to say something?
Hey, Harsha, sorry. Can you hear me?
yeah. Can hear you,
Yeah.
Kader.
Yes,
Talk,
Kyle.
talking on mute. Yeah, please go ahead.
So, Mickey, man. First, I want to say thank you for taking your time to educate us on new techniques. And I'm a novice. Like when I say novice, this is my first So I just started school in the beginning of September for computer science. So all this stuff here is as my eggs scrambled, meaning I don't truly understand uh, everything that's going on. I mean, I understand like the concepts when you're talking, some stuff, but my main focus is, and what I'm getting at is Mickey is my main focus is, I want to become a machine learner engineer, right? And kind of like maybe what's your advice on someone in today's world, in today's industry of technology? Like what would you say my focus should be for the next couple of years on getting educated and getting qualified to become, you know, where I want to be as far as machine learning?
So, sorry, I don't know whether I got the question. So, are you
So,
asking
you
for
know
how
what
we
I
need to
recommend,
proceed for
right?
this?
Hey, Harsha, what I recommend, the question is that he wants to become a machine learning engineer, right?
Okay.
And what does he need to do, right? So that is an offline discussion. Dimagio, I think are you in the Microsoft Teams of Testoper, please?
Yeah.
Yeah, because I see you have joined in outside of your organization. So you can actually reach out to Harsha in the Microsoft Teams from Testoper Microsoft Teams, and then he will be able to help you offline on that, right? I just want to make sure that this is an offline discussion, one-to-one mentorship discussion to be taken out offline.
Okay. So what I do just you said Harsha.
Yeah.
Yeah,
Another way is one is through Teams. If you want, if you have some specific questions or something, send me a mail. We can arrange for a meeting in Teams, and we can have a chat. I'll be very happy to guide. I've mentioned my mail in the chat. You can send it to that too. Reach out to me on Teams or through email, one of
Okay.
these,
Thank you.
and we can fix a time and then we can have a chat.
yeah.
Okay.
So it's good, Harsha, right? We have crossed our, the standard numbers, right? So we'll have our next week session as well, Harsha.
That's thanks for this. And I was going by the discussion we had last week. I deliberately reduced the number of topics and kept it to 45 minutes. Maybe next week we can look at going the full session, so that like I also have topics to cover. So I'll make it a full session next week. Then I see the numbers are as you mentioned, Kader. It's above our threshold. So thanks for that, and we'll have a full
Yeah,
session
please,
next week.
please make sure every one of you join next week's session to continue to learn from Harsha. I would really appreciate it. Thanks a lot, guys. You have a wonderful long weekend, at least those who are in Canada. And remember, if some of you guys are looking for a job just send me your resumes. There's a lot of partners do that. I'll also share my email address if you. I'll share like Testoper at Testoper. It's easy to remember. Testoper at testoper.com. Send me your email addresses. Sorry, send me your resumes. I'll be happy to look through, and if there is a requirement, push it on, right? Wherever applicable. Yeah, so that's pretty much Harsha. Honored to close the session. Yeah.
Okay. Thanks a lot, guys. See, NLP can be overwhelming. Don't worry, I'm just introducing the topic to you. And at next session, we'll also discuss like how we can take this forward, like what can be done for you to continue with that, because this is an ocean. It's a different stream in machine learning. It's totally different and a very prominent stream, I would say, because see, the goal of NLP is to increase human machine interaction. You can see it in many places, right? So it could be written text, it could be voice text. Um, uh, you're seeing Alexa, you're seeing, what is happening with several chats, service chat bots which are there. So this is definitely a huge area how things are being done. It is at a level where they're also saying the model can build a story on its own, right? So write a story on its own content, written content, it's that level. So it's going to be very big, and I'm only covering not even tip of an iceberg. It's a very small portion I'm covering because as one of the participants mentioned, they're starting with machine learning. So I cannot get into model building everything now itself, right? So I'm introducing the basics. After next session, what I will do is I'll also cover like what you can continue with, like what can be some sites which you can continue with, what can be some courses which you can take. I'll cover that too in the next session. Thanks for the participation in spite of it being a long weekend here in Canada. Uh, uh, Talk to you again next week, and we'll make sure that next week is a full session.
Thanks, Sarsha.
Thank you. Bye. And
Thanks.
last point, sorry, the file and the presentation are already in the Teams folder.
Perfect, perfect.
Thanks,
So
Aaron.
thank you, Professor Samuel Singh.
Thank you.
All right.
Thank you.
Take care, guys.
Bye.
Let's talk next week. Bye.
Thank you.
Thank you. Bye.
Thank you.